All right, today we're diving into a technology that's basically teaching AI how to do its homework. It's called Retrieval-Augmented Generation, or RAG for short. And honestly, it's the difference between an AI that's just guessing and an AI that actually knows what it's talking about. So, you've probably been there, right? You ask an AI a pretty straightforward question, and the answer you get back is just completely weird. Maybe it makes up a historical event, or it tells you it has no idea what happened after 2021. It's a super common thing, and it points to a really big weakness in how these models work right out of the box. The reason for all those strange answers really comes down to two main problems. First, there's the knowledge cutoff. You gotta remember, an AI model's knowledge is basically frozen in time, like a textbook printed in a certain year. It doesn't know anything that's happened since. And second, and this one is even weirder, is what we call hallucinations. This is when the AI doesn't know the answer, so it just makes one up and says it with total confidence. Honestly, the best way to think about this is with a simple analogy. A standard AI, it's like a student taking a closed book exam. It can only use what it's managed to memorize. But an AI with RAG, well, it gets to take an open book exam. Before it answers your question, it can look up facts from a whole library of current information. And that one little difference, it changes absolutely everything. So when an AI's memory is all it has to go on, you start running into some pretty serious limitations, and they have some very real-world consequences. There are really three big ones to worry about. We already talked about the knowledge cutoff. Ask it who won an award last month, and a standard model is just going to have to guess. Then you got the hallucinations, where the AI just flat out invents things. But the third one is a huge deal for any business: a lack of specificity. A normal model can't see your company's internal reports, or the latest financial data, or private legal files. Its knowledge is totally generic. So how do we give our AI that open book superpower? Well, the solution is a technology with that mouthful of a name we mentioned earlier: Retrieval-Augmented Generation. So what is RAG really? Simply put, it's a system that connects a language model to a separate external knowledge base. But the secret sauce is the order it does things in. The model first retrieves the facts it needs from that library, and only then does it generate an answer based on those facts. Retrieve, then generate. Okay, so what does this actually look like under the hood? It's a pretty elegant process that breaks down into four main steps to get from your question to a smart, fact-based answer. Let's just follow the journey of a single question. First, the system is given a library of trusted knowledge. This could be anything from news articles to internal company wikis. Now, when you ask a question, the system instantly searches that library and retrieves the most relevant snippets of information. Then comes the magic, the augmented part. It takes your original question and stuffs all those facts it found right alongside it, creating a new supercharged prompt. And finally, it hands that new prompt to the AI, which can now generate an answer that's actually grounded in real, provided context, not just its fuzzy memory. Look, understanding how it works is one thing, but the real-world impact is what makes RAG such a total game changer. This isn't just about getting trivia questions right. This is about building AI that we can actually trust. And the benefits are just massive. Accuracy goes way up because the answers are based on actual data. Because of that, hallucinations basically disappear. And here's a huge win: transparency. The system can literally show you its work. It can cite the exact documents it used to come up with its answer. Plus, it's way, way cheaper to update a document library than it is to retrain a giant AI model from scratch. And finally, customization. You can point this at your specific, private data and create an expert on any subject you need. And sometimes, the stakes are just incredibly high. I mean, think about it. A medical chatbot that's giving out outdated treatment advice isn't just wrong, it could be genuinely dangerous. But with RAG, that same bot can pull its answers directly from the very latest clinical research. That's how AI goes from being a novelty to being a mission-critical tool. You can see how this plays out everywhere. Your customer support bot goes from kind of guessing about new product features to giving you exact specs from the official manual. A financial tool goes from using last year's market data to analyzing real-time reports. And for a lawyer, it's the difference between an AI that literally makes up a court case and one that finds the most relevant recent legal precedents. It's a night and day difference. RAG is already so powerful, but believe me, this is just the beginning. The core idea, just letting an AI look things up, is starting to expand in some really cool ways. Things are moving fast. Right now, we're mostly searching through text. The next step is hybrid RAG, which will let AI search through documents and structured databases at the same time. After that, we're looking at multimodal RAG, where an AI can find a specific frame in a video or a keyword in an audio file. And the ultimate goal? That's agentic RAG, where the AI doesn't just retrieve information, it actively uses it to complete tasks for you. What we're seeing is a fundamental shift in what AI is, removing it from being just a memorizer to being a researcher. By giving it the keys to the library of human knowledge, we're making it more current, more trustworthy, and infinitely more useful. And that really leaves us with one heck of a question to think about. Once AI can read everything, what are the truly important questions we'll finally be able to ask it?
To furthermore add just in the video, as you can see the basic RAG workflow. The process begins when a user submits a question or prompt such as what is RAG? This query needs to be processed and to find relevant information. The initial question or prompt from the user. This is the starting point of the RAG pipeline. So the next is embedding. The user query is converted into numerical vector representation such as embedding model. This transforms text into high-dimensional vectors, typically 384-1538 dimensions that capture semantic meaning. The next step in the pipeline is vector database. Stores document embedding for efficient smartly search. Options includes like FIAS, Facebook, AI, Pinecone, Managed Cloud, Chroma, and sports operation like cosine similarities, dot product, etc. Right? Number four is actually retrieve docs. The top k most relevant document, typically 3 to 10, are retrieved based on similarity score. These documents contain the contextual information needs to answer the query. Number 5 is LLM processing. The retrieved documents are combined with the original query and fed to the large language model GPT-4, Claude, Llama, etc. The LLM uses this context to generate an informed response. Number 6 is actually response. The final output is grounded answer that combines LLM language capabilities with the factual information from the retrieval document. Let's move to the advanced RAG architecture with the component based. So we were talking about the RAG architecture. Doc- First of all, actually, we are going to see the document processing layer, PDF parser. Extract text from the various document format. What's the use of the text chunker? It's like breaks document into manageable pieces, typically 512 to 1024 tokens. Meta extract capture documents metadata, author, date, categories. Pre-processing cleans and normalize text data. What we are going to do in the second embedding layer, uh, multiple model options, sentence BERT, OpenAI ADA, custom models, we can use any of them. Number third layer is actually storage and retrieval layer. So what we are going to do over here, vector databases like FAISS, Python, Vivid, Elasticsearch, and so forth, and Chroma. So there are different options we can use it. Number four is generation layer. GPT-4, Claude, Llama, we can use any LLM selections. Context integrations perspective, we combine retrieve document with the user query. Response generation produce factual grounded answer. So that's the where we actually generating the actual response, right? Let's move to the second option, like the chunking strategy. How we are actually going to do that? Document segmentation, like see if we have received this original document and how we actually make different chunks within it and get the retrieval information. Large documents are broken into smaller overlapping chunks to maintain context while fitting within LLM token limits. Chunk properties normally based on like size 512 tokens typically per chunk. Overlap 128 token overlap between the consecutive chunks, right? Number third, like then preservation maintains semantic coherence across chunk boundaries. Vector representation is actually like the space. Each chunk is converted into an embedding vector and stored in vector database with a positional metadata. Let's move to the hybrid search, the most interesting point over here. Three search methods: semantic search, keyword search, metadata filtering. Semantic search like vector similarity using cosine distance. Keyword search, traditional BM25 TF-IDF ranking, right? The third one is actually metadata filtering, data range, categories, and document types. Result fusions, like based on that, how we are actually going to achieve the results. Combine result from the multi search methods. That's the objective. Weight scoring, balance semantic relevance with the keyword match, whatever we are searching over here. Like for example, latest RAG technique, what we are searching. Final ranking produce optimized document retrieval. So last but the least, what's the usage of this RAG performance metric is retrieval precision is 90%, 92%, uh, 92% relevant document retrieved, response latency 234 millisecond average query time, context window 8K tokens per request, accuracy improve a lot percentage 47 versus vanilla LLM, right? Evaluation method, we can use different evaluation method: precisions, recall, measurement, F1 score calculation, mean, uh, MRR, normalized discounted cumulative gain, NDGC, right? So we can use different evaluation method to perform to test the accuracy and performance. Thank you.